Okay, this is your chapter 4 lecture guide. You can see the table of contents there. We'll start with solutions and concentration. A solution is a mixture of two or more substances where at least one of those substances is dissolved into another substance. The solute is a substance that is dissolved or is present in a smaller amount. The solvent is a substance present in a larger amount or does the dissolving. You can have more than one solute per solvent. That is, I could dissolve salt into water, for example, and that would be a solution where salt is the solute and water is the solvent. If water is the solvent, then we call that aqueous. Concentration defines the amount of solute dissolved per amount of solvent. A common unit of concentration is percent by mass, and it's defined as the mass of the solute divided by the mass of the solution times 100%, where the mass of the solution is the mass of any solute plus the mass of the solvent. So if we look at this first example, we want to know what volume of 12% potassium hydroxide contains 40 grams of potassium hydroxide if the density of the solution is 1.11 grams per milliliter. Here we're going to use percent by mass and get the volume using the density of the solution. So in this question, I copied all the data over. So we're going to start with the 40.0 grams of KOH. And one thing we can do is use the percentage as a conversion factor. So we're going to put 12.0 grams of KOH per 100 grams of total solution, which I'll abbreviate SOLN for space sake. What does that do? It allows us to cancel things out. And since I did it per 100, it's the same as the percentage. Then I can use the density to get volume. So I can say 1.11 grams of my solution, and then per 1 milliliter. And so grams of solution are going to cancel, leaving me with milliliters, and I would get 300 to 3 sig figs milliliters. And that would be my answer. Could you do it as two separate problems? Could you work a percentage problem and then work a density problem? Sure, but this is, using the dimensional analysis is a bit more efficient than that. In this next question, we're going to calculate percent mass by dissolving 25.2 grams of potassium bromide in 250 milliliters of water. Here you've got the solute and the volume of the water. If we use density, 250 milliliters of water can be 250 grams of water, and that'll help us get the mass of the solution. Okay, if we look at this particular problem, I've got the mass of the solute, KBr, the mass of the water I added, but that's not the mass of the solution. So if we do percent KBr, we're going to put 25.2 grams of KBr. Then underneath it's going to be 25.2 grams of KBr plus 250 milliliters of water. So we're working it much more like a straight percentage problem in this particular case. And you'll get 9.16%. And that would be your answer. The most commonly used concentration unit is the molarity. Molarity is defined as moles of solute per liter of solution. So molarity is moles divided by liters. Or you could say millimoles per milliliter. That can come into play, but we'll focus more on moles per liter in this particular course. So let's look at this next example. I want to calculate the molarity of a solution that contains 12.5 grams of sulfuric acid and 1.75 liters of solution. All right, we were asked to calculate the molarity of 12 grams of sulfuric acid and 1.75 liters of total solution. So you could work this all as dimensional analysis, but we can split it up so it'll make a little bit more sense. So we start with the 12.5 grams of sulfuric acid. Sulfuric acid, I'll give you the molar mass for time's sake, is 98.09 grams of sulfuric acid per 1 mole of sulfuric acid. Now, that'll give you the moles of sulfuric acid, which is 0.127 moles. That's our intermediate. Now, if we want the concentration of the sulfuric acid H2SO4, that bracket notation generally indicates molarity of the substance in brackets. So 0.127 moles divided by 1.75 liters, and you'll get 0.0728 moles per liter, or 0.0728, the capital M, meaning molarity, and that's red, molar, like one of your back teeth, so 0.0728 molar solution, and that would be your answer to the question. This next question is a little bit more how you would do it in a prep lab, and once you get into chemistry, it's probably the more useful problem. We want to calculate the mass of cupric sulfate required to make 500 milliliters of a 0.1 molar solution. So here you're trying to make a particular solution. You don't know how much cupric sulfate to weigh out. That is going to be the more practical problem as you move forward. Okay, and this one we want to know the molarity or the mass of the cupric sulfate that produces this molarity of solution. So what we're going to start with is the volume of solution we want, 0.5000 liters, and then use our molarity that was provided, 0.100 moles per liter of cupric sulfate. Now, if I want to know the mass, I have to multiply by the molar mass, and I'll go ahead and give that to you for time's sake, 159.6 grams of CuSO4. Go back and add these up and make sure you can still do it. And so we see the liters cancel, the moles cancel, and we're left with grams. And that's going to be 7.98 grams of cupric sulfate. And that is going to be your answer. Let's talk about dilutions. Dilution means that you're going to add a solvent to a more concentrated solution to make a solution less concentrated or more dilute. Those are rather vague terms. Concentrated means you have a lot. Dilute means you have a little, or at least less. But it isn't specific about the exact concentration of the solution. This is how fountain drinks were made from syrup. We add carbonated water to dilute the syrup to make our soft drink. Number of moles of solute in the two solutions remains constant. The formula is M1V1 equals M2V2. The volumes can be in milliliters or liters or whatever. And the concentration units can be whatever as long as you're consistent, because everything cancels across the proportion. So this equation will work for dilution, but not a chemical reaction, because this formula assumes that the moles of solute are equal in both solutions. And if the stoichiometry is not right, then that won't work. So let's look at this next problem. If we got 10 milliliters of 12 molar hydrochloric acid added to enough water to give 100 milliliters of total solution, what's the concentration of the solution? So the second volume is always the concentration of the solution. We got the initial volume, initial concentration. It's just working out a simple proportion problem. Okay, so let's look at this problem. 10 milliliters of solution to 100, 12 molar to what after we dilute it? We're going to use our formula M1V1 equals M2V2. We're going to solve that for M2. So M2 equals M1V1 divided by V2. So 12 molar times 10 milliliters. We're diluting it to a volume of 100 milliliters. Milliliters cancel, so see, I didn't need liters at all. but that's going to give me 1.20 molar solution, about what you'd expect. Change the volume by a factor of 10, you're going to change the concentration by a factor of 10. In this next problem, we want to know how much water must be added to 50 milliliters of a 6 molar solution of sodium hydroxide to dilute that concentration to 4 molar. Now, here, I've given you the initial amount, but I ask you for how much water. So what you calculate from the equation is the total volume of the solution. So we'll have to subtract the initial amount to find out how much water we actually had to add. So that's the wrinkle for that particular problem. Okay, so in this problem, remember, we're trying to find the water added, not the final volume, even though we're going to calculate it to get there. So in this case, we'll solve for V2, realizing that's not our final answer. V2 equals M1 V1 divided by M2. So M1 is 6 molar, 50 milliliters divided by 4 molar. Molarity cancels this time, leaving us with milliliters, and that will give us 75.0 milliliters, but that's the total solution. How much water? Well, I had 50 milliliters before, 75 now, so the volume of my water is going to be 75 milliliters minus my 50 milliliters, equaling 25.0 milliliters. And that is our answer. But a common mistake would be the 75, because you get the second volume, you just run with it. But what you want is the amount of water you had to add.